Okay, good morning, everyone. Today, in today's lecture, we will discuss one of the very important research problem that is used in the cloud computing. That is called as the resource allocation problem, right? So, in this resource allocation problem, I will tell you the problem. But before telling the problem, what are the basic terminology used for this resource allocation problem? Like leads. Leads is a term used in the resource allocation that we will discuss first, right? So once that part is over, then I will formally define what is resource allocation problem, what are the things you have to consider in order to define the resource allocation problem, and then we will see what are the approaches that are applied by various researchers to this resource allocation problem, right? So the first terminology used in the resource allocation is called as leads, right? You may have heard this term whenever there is a tendering process, okay, going on. That at the end of the tendering process, you are saying person X got this lead, right? So lease is nothing but a contract. Like I told you, service level agreement is also a contract, or in software engineering, SRS document is a contract. So lease is also one type of contract, right? And lease has a difference if you compare lease with your task, what we are repeatedly referring in various lectures. So if you see this lease and task has little bit differences there, right? So lease contain more things, but task contain very simple things, right? In lease, everything you need to clearly define. How many nodes you require, what is the duration of using that node, right? What is the deadline of the node? Okay, what type of quality of service you want from that particular node? Everything you need to define in a formal way. That is called as your leads. So, in this problem, what we will take? We will take a 4-node cluster. You know cluster, right? A 4-node cluster means you can assume that there are 4 different nodes are there. They are connected to each other. And these 4 nodes want to provide services to the based upon the user requirement. They are doing some work for the user. Right? User is going to pay for that service. So with a small illustration, I want to explain you. But if you go for the data center or go for the cloud computing, you can see this cluster size is very huge that you have seen in the top 500 or 200 website as well. But as an illustration purpose, what we have taken here, we have taken a very simple one, that is 4-node cluster. They are represented in here. If you see node 1, node 2, node 3, and node 4 respectively. Okay, and order of this node is given here. Right, this order of this particular node is given here. Right, and based upon the user application or based upon the user requirement, user can ask you at the next 4 nodes because you have maximum of 4 nodes. Right, beyond 4 it is not possible because your limitation, your resource, maximum resource you have, that is 4. Right, this is a small illustration, but if you go for real life examples, the number of nodes is very high, or which we can say infinity. Okay, infinity means we cannot ask that much node, or for our application, that much node is not required, or sum of all the user requirement also is less than this infinity. That's why we say cloud has unlimited number of resources. But in practical sense, it has a limited number of resources. Okay? So what you will do whenever a user is asking for you the resources, what you can do? You can assign these 4 nodes to the user with respect to the time. That's why x-axis represents the time. Like somebody may ask the resource slot like this. Somebody may ask the resource slot here. Somebody may ask the resource slot here. Something like that. Okay. So with respect to time, you are going to assign the resources to the user. Right? You want to lease the parts of the cluster over the time based upon the customer requirement, you are going to assign your resources to the users, right? So very simple illustration will take to understand the things. Once it is clear, I will give you a data set, right? You have to run the data set in a by write the codes. Okay, the data set I will give you. That data set, for that you have to write some programming language. Okay, you have to take help of programming language, and you have to simulate it, and you have to see that which algorithm is performing better, right? Now, the very first lease, what we can ask, lease is also various type, like lease is various types. First type of lease called as your advanced reservation lease. This advanced reservation lease is same as our railway ticket reservation, right? For example, suppose I want to travel from a place A to place B, okay? So what I need, I have to book a ticket, reservation ticket in a 2 AC or 3 AC or in sleeper, right? I have to book a ticket, and my whatever seat is allotted to me, whatever berth is allotted to me, or whatever coach is assigned to me, that particular position is remaining with that customer from the beginning of the journey to end of the journey, right? From this A place to B place, right? Once B place, you have reached B place, you have to release your things so that another person, if he booked in that particular berth or coach, he will continue in that particular seat to continue to another position, let's say C, right? In the similar fashion, here we are using the advanced reservation link. So you can see here, first let us see this example, then I will tell you the theory part. In advanced reservation lease, one person requested the lease at 1 p.m. Okay, and he need the resources up to 2 p.m. Right? He requested to cloud service provider. He required 3 nodes. You can see node 1, node 2, node 3, node 4 is not required. Node 1, node 2, node 3 or 3 nodes. Out of these 4 nodes, he require in between 1 p.m. to 2 p.m. So it may happen that the request reaches to the cloud service provider at 12 noon or 11 a.m. or 10 a.m. means prior to 1 p.m. and cloud service provider has reserved that release in the cloud. Like your 4 node cluster, we have reserved 3 resources out of 4, right? So in order to request the cloud service provider, so there is a specific format in which you can request to a particular cloud service provider, and you have to formally define what is your user requirement. Like I told you about VM template. So here if you see, if you want to submit your lease as an advanced reservation lease, you have to specify 2 things. One is your start time, which we call as beginning time, and you have to specify your end time. Like here, if you can see, the start time is 1 p.m. Okay, end time is 2 p.m. These 2 things you have to specify if you are submitting in the advanced reservation lease mode, right? Or one person can say, I will specify the start time plus duration. Duration is my 1 hour. So I can say it is also okay. Without specifying end time, if you specify the execution time, okay, or the processing time, okay, then I can estimate what is your end time. Okay. So in order to specify the lease in the advanced reservation mode, you have to specify these 2 things. One is begin time, another is what is your end time. Okay. And if you go for a mathematical definition, in the mathematical definition, I can say I can represent this advanced reservation lease in the form of a 4 tuple, right? For example, a lease advanced reservation lease AI is equal to SENT, where S is the start time, E is the execution time, N is the number of nodes, T is the execution time. I'll come to this execution time. So in this case, if you see, this is suppose this is the AR is A1. So I can define this lease as A1 is equal to, the first one is my start time is your 13, right? Next, execution time is our 1 hour. Number of node I require is 3, and there is a execution time. So execution time I have taken here to illustrate you whether this lease is printable or non-printable, that you have studied in operating system. If in between the execution you are able to print a particular process, then you can say it is a primitive mode, primitive in nature. But if you are not able to, once you are assigning a particular process to the operating system, you are not going to print it, or even if you are print the operation is not allowed, then you can say that is called as a non-primitive nature. That's why I have taken the things is T, right? So the lease says lease starts at 1 p.m. and ends at 2 p.m. or lease start at 1 p.m. and it should continue up to, and it should continue for 1 hour. In this way, you can define the advanced reservation lease. Out of all these, all the leases, whatever we discussed today, AR lease has highest priority among all. Among all the leases, AR is having highest priority, right? And the other hand, you can say, if you are submitting the lease in the advanced reservation lease mode, you have to pay more because you are going to occupy the lease, okay, by beating other leases, right? Or by printing other leases, right? Come to the second one. Second one is called as a best effort lease. Sometimes what happens? Urgently we want to travel from one location to another location. For example, Warangal to Hyderabad, we have to go to appear for a personal interview. Okay, suddenly it is planned and you have checked the ticket and the ticket is not available. So what you are going to do? You have to immediately start. You have to go to the Warangal or Kajipet station and you will book a ticket that is called as a normal ticket, or you can say unreserved ticket, right? What is the meaning of this unreserved ticket? Unreserved ticket means you can board at any train or the next train within 3 hours. Okay, you can book the ticket within 3 hours, whatever train is there, you can go travel, or the next train also you can travel. So here what we are doing, here we are not specifying what is the start time and what is the end time, because we don't know, right? We do not know what is the train status, which want to travel, I don't know, right? So as soon as the train is available, I have to board that train and I have to travel, right? That's why this best effort list says we know that we need resource, we know that we want to, but we don't know that at what time will start and what time will end. Okay, that is the thing is we do not need that at a specific time. We need resources, but we do not know at what time we require the resources. Okay, so we are perfectly content to wait until there are enough resources available for our needs. For example, it may happen that one train will come, it is fully loaded. So you will say that no, I'll wait for the another train. It may possible, right? Because if enough number of things are not available, enough resources is not available, you are ready to wait. Right? Like you can see, here there is a best effort lease. That best effort lease require one node. It has not specified what is its start time, or not the execution time, nor the end time, right? But execution time you need to specify. You will not specify your start time and end time, right? As soon as the resource become available, your lease will be allocated with the resources in order to execute it. Okay, so it may happen that multiple people are accessing the system, like multiple people want to travel from Kajipet to Hyderabad. So what you will do in this case? In this case, you have to keep all the requests in the queue. Like whenever we are entering to train, especially in this COVID time, there is a queue. Whoever there in the queue first, he will get. He is more likely to get the resource. otherwise you have to wait. So when we request a best effort lease, our request get placed in a queue. That queue means that is a FCFS order or first in first out order, and you have to wait until unless the resource is available. Next the question may come, if there is a advance reservation lease and there is a best effort lease, A are specifying the start time and end time. Best effort specifying only the execution time. There is no specific start time and end time. Who is having highest priority and what will happen whenever a B lease is executing and AR lease is entering the system? Like in this diagram, you can see an AR lease has more priority over the B lease, as I mentioned. AR lease has more priority over all the leases, you can say. Hence, it can preempt the B task on its arrival. Like in this case, you can see one best effort lease is taking one node resource, and it starts its execution here, right? It starts execution at this particular time. When it reaches at this particular time, okay, one advance reservation lease is requested. At this particular time, one AR is already requested. So what we will do? We will preempt this best effort lease and we will give priority to AR lease. Once AR lease is completed, we can resume the best effort lease. Right? So what we can say? We can preempt the best effort lease and we can start the AR lease and we can resume the best effort lease once AR lease is completed. That's why we say AR is having highest priority in comparison to the best effort lease. Okay, but a B lease cannot preempt another B lease. Suppose one B lease is there, another B lease is coming, they should be kept in a queue. We have to maintain everything in a queue. You cannot say B lease is preempting another B lease. On the other hand, you can say AR application cannot preempt an AR application. For example, here AR application is running. At this point of time, if you assume another AR requested to that same cloud service provider, so that AR request will be rejected because AR cannot preempt another AR lease. Right? That's why this best effort lease is called as preemtable best effort lease. It is of two types best effort lease. One is called as non-preemtable, another is preemtable. In this diagram, whatever you are seeing, that is called as a preemtable best effort lease. Right? Come to non-preemtable best effort lease. Non-preemtable best effort lease says once you are allocated the resources or assigned the resources, you cannot preempt even if an advance reservation lease is entering the system. Right? For a second example, I have taken here, you can see, I have taken a non-primitive best effort lease which arrived to the system at 6 a.m. Right? It requires a 1 hour slot. Okay, 1 hour slot for 4 resources. 4 resources means in this diagram I have taken 5 nodes. Out of 5 nodes, it requires 4 nodes. Okay, 0 indicates it is non-preemtable. 1 indicates it is preemtable. So what will happen? In this case, it will start, let's say, up from the 6 to 9 a.m. Okay, 6 to 9 a.m. all the resources are preoccupied. But at 9 a.m., the resource is free. So what we did here, from 9 to 10, a 4 node 1 hour slot is assigned to this non-primitive best effort lease. Right? And it is expected to complete at 10 a.m. as its execution time is 1 hour. But once it has started execution around, let's say 9:10 means at this point of time, a advance reservation lease is entering to the system. And that lease says, I need to start my execution at 9:30. I require 1 hour, but I require 5 nodes. If that lease require 1 node, then there is no problem because 1 node is available. But that lease require 5 node with obviously advanced reservation means it is non-preemptable. So this lease is rejected because we cannot execute because it is in the non-primitive best effort mode. Rather than what we can do negotiation with that user. Negotiation means we will say that we cannot provide the resources at 9:30, but if you change it to 10, right? I promise you to provide the resources for 1 hour. If the user agree using this negotiation, then we will assign the A2 from 10 a.m. to 11 a.m. Otherwise, what we can do? We can reject that list because our resource is not sufficient in order to accommodate A2. So while you are accommodating the leads, you have to ensure that you are going to complete the lease as per the requirement. Otherwise, the SLA will be violated. If SLA is violated, then what will happen? You have to pay to your customer or some penalty will be charged to the cloud service provider. That's why you have to ensure that whatever leases you are accepting, that is possible to accommodate using your existing infrastructure or whatever resources you have. With that resources, you are able to handle it. Otherwise, you simply reject it, right? Third type of lease is called as your deadline sensitive lease. Here, the new term is coined that is called as your deadline, right? So, in the best effort lease, it is the advanced version of you can say best effort lease, right? Or a modified version of the best effort lease. You know, best effort lease, whenever you are submitting, you are saying you require 1 hour, but you are not mentioning what is the start time or what is the end time. So, you require 1 hour. At what time? I don't know. It may be 10 to 11, it may be 11 to 12, it may be 11:30 to 12:30. I don't know, right? That's why what we are doing, we are adding another parameter to the best effort lease. That is called as your deadline, which we call as your deadline sensitivity. So in this case, what we are doing, we are asking for a suppose let's say 1 hour slot, but we are saying you have to complete this best effort list, which we call it your deadline sensitive list, before let's say evening this. You have submitted the list now, and you inform the cloud service provider, I require 1 hour slot. Suppose you 10 a.m. you have submitted, you require 1 hour slot. But you say to the cloud service provider, I need the resource before 5 p.m. Right? You give any slot, I don't have any problem. 10 to 5, any 1 hour slot you give, I don't have any problem. It may be 12:37 to 1:37, it is okay, no problem. But I need 1 hour resource before 5 p.m. So 5 p.m. is my deadline. So you can see here I have defined a deadline sensitive list. That deadline sensitive list is requested, is reached to the cloud service provider at 9 a.m. It requires a 1 hour slot. It requires 5 nodes, 5 out of 5 nodes. Okay, it is in the primitive mode. Once it gets it is in the primitive mode, you can print also. Like your resources will be provided to you using 2 30-minute slot. It is also okay. It may be 10:30 to 11, another may be 4:30 to 5. It is okay. And the lease need to be complete by 12. By 12 noon, you have to complete this best effort lease, which we call here deadline sensitive. Without if this parameter is not there, then we call this is a best effort lease. If this parameter is there, we call it a deadline sensitive lease. So once you are requesting such scenario, what happens? The cloud service provider may give you from 10 a.m. to 11 a.m. or it may give you from 11 a.m. to 12 a.m. Or it may give 10 to 10:30. If your deadline is 12 noon, it may give 11 to 11:30. 2 30-minute slot is also okay. 4 15-minute slot is also okay. Right? That is possible. Anything that can provide that because it is in the primitive mode. So that is called your deadline sensitive lease. Next type of lease is called your immediate lease. Immediate lease is nothing but your current booking. You know, in railway reservation, there is a current booking. Once the chart is prepaid, Okay, if some seats are vacant, then it will be booked by the customer. Okay, or the passenger. What the meaning? You can book the ticket and you can board the train immediately. So immediate lease is a type of lease which may evolve in the future into an urgent lease. Where right now really that does mean right now. I need the resource now means I need the resource now only. Otherwise, you have to say that no resource is not available. For example, a lease is received by a cloud service provider at 11 a.m. Then it needs to start that lease at 11 a.m. only. Okay? A lease is arrived to the cloud service provider at say 11 a.m. Then it needs to start the lease at 11 a.m. What you can conclude? The arrival time is same as the start time. The time in which the request reaches to the cloud service provider, that is the arrival time, is same as your start time. Okay. So these leases are used in a popular resource manager, which is the open resource manager. It is called as your hygiene. So please explore this word, hygiene. It is an open resource manager in which these leases are used. Right? So here what you can see in the diagram, at this point the resource is requested and immediately it is, otherwise you have to immediately reject also. If you don't have the resources, you say that no, it is not practically possible. Right? This is a important list in which you require the lease right now, then you can go for this immediate lease mode. The next one is called as your deadline sensitivity, also called as your best effort with deadline. Deadline sensitivity is same as your best effort with deadline. So here the term is says best effort but be reasonable. Okay, I require 1 hour before let's say 5 p.m. From now onwards, I require 1 hour up to 5 p.m. Okay, but you should not violate the deadline 5 p.m. Okay. So what you can say, as soon as the resource become available, it will be provided, but subjected to this condition. As long as my lease does not start or end any later than the deadline. Okay. Or you can say deadline at 4 p.m. If you require a 1 hour slot, you can say before 4 p.m. if you complete the lease. Okay. Or at 4 p.m. you are bound to give resources to me. Because if you start at 4 p.m., then only you can complete 1 hour slot at 5 p.m. Or you can say 4 p.m. Before 4 p.m., you have to give 1 hour slot. That's why minimum the things you can say by 3 p.m. By 3 p.m., if the resource is not started, it needs to start before to complete before 4 p.m. So such type of deadline you can force to the best effort lease, that is called the best effort with the deadline, or it is called a deadline sensitive lease. So these are the various modes in which we can request the resources to the cloud service provider. Next one is a very interesting lease, that is called your negotiated lease. I told you about negotiation, but there is a specific lease that is called your negotiated lease. So let us see the diagram, then we will do the theory part. So here there are 4 nodes. One user has requested you some hour and some nodes, and he is ready to pay $100 as you are going to provide the resources to that particular user. The user is going to give you $100, right? Once the deal is completed, as per the SLA, the user is going to pay you $100. But what happened? The cloud service provider has seen, of course, after committing with you, right? It has seen that some other leases also requested at that particular time, where it gets more benefit. Like you requested with $100, Suppose another person came, he requested $500. So definitely the cloud provider want to go for $500 because more revenue will generate. But at the same time, it cannot violate the service level agreement, right? Service level agreement we cannot violate, right? Once you commit, you have to do it, otherwise the penalty charge will be uh, imposed, right? And it will also leads to the reputation of the cloud service provider. Okay, if frequently the cloud service provider is doing like that, then what will happen? Then people will say that no, that the cloud service provider is not good. So one interesting thing the cloud service provider is doing, he's saying instead of giving the resources at this particular time, he's requesting the user, if you start the lease after 1 hour, let's say 1 hour, then I will give you the resources with a flat price of $50, 50% off. 50% off, that is $50. You did not pay $100, you have to pay $50. Only thing is that you have to start your lease after 1 hour. Similarly, after 1 hour also the resources is booked. Okay, resources is going to be booked by some other provider where cloud service provider is getting more money. So the deadline again requested to that user to extend the deadline by another 1 hour and you pay only $25. It is okay for you. If the user is not going to accept your negotiation, then you fail, right? Your approach is failed. You are going to provide the resources as per the SLA. Or you have to ask some other cloud service provider who is going to provide you the resources and it will host your application in that data center. Like that, it is extending the deadline and finally saying, okay, $10 is also okay. I will go give you the resources, but you extend the deadline. So if user is flexible, user requirements is not that much important. Okay, user does not require the resources urgently, then it can extend. Otherwise, user will say no. So interesting scenario you can see here. Sometimes what happens, not only in the price, they will say you require one node at this particular time, but if you extend the deadline by 1 hour, I am going to provide two nodes. It's 200% of the resources with 50% price, right? So such type of things can be possible by the help of this negotiator, right? Like that, you have to do negotiation and you have to accommodate multiple needs, more than one customer, and you have to satisfy the requirement of more than one customer. Then finally, your revenue will be maximum and the customer satisfaction will also increase. Okay, that's what it is saying. I will even throw a discount and free air condition. Or it is saying, I get you twice the resources at the off-peak time. Like I told you in the pricing mechanism, there is a off-peak time, there is a on-peak time, or peak hour. So if one person is requesting at the peak hour, what you can do, you will say that no, peak hour resources are not available. But if you request the same thing in off-peak hour, I am going to provide you twice of the resources with the 50% discount. So such type of things you have to do. You have to accommodate more than one customer or multiple customer at the same time. Next is called as a period reservation. Period reservation is a new type of lease. What it is saying? It is saying I am not requiring the resources at the same time. Okay. For example, I require 3 hour resources. It is saying no, I don't require 3 hours consecutively. I require 3 hours in a different span of time. You give three span of any three span time, it is okay. Like my speech is executing 1 hour, then you are printing me. Another 1 hour you are giving in the afternoon. Another 1 hour you are giving in the evening. That is okay. So you can see at 9 a.m. the lease arrived to the system. It requires 3 hours of time. Okay. So it can give 3 hours at the same time. Cloud service provider if the resources available. So cloud service provider can provide 3 hours leases. If 3 hours is not available, then cloud service provider can give 1 hour in 3 different slots, or half hour, 30 minutes in 6 slots. It is possible. However, how many times you can print this thing, that is also defined. Right? The number of prints should not exceed 4 times. The number of prints should not exceed 4 times. Okay, that's why it is written 4. At the max, you can print that list for maximum of 4 times. Beyond that, there is a violation of service level agreement. Okay, so this is a special type. That's why I've given the number is 2 to indicate that you can print, but subject to some condition. And you have to complete the lease before 5 p.m. Okay, in the number of nodes, it will require these 3. This is not 3. This is there is a typing mistake. This is 4. You require 4 nodes. So see here, as you require 3 hours, what we are going to provide, cloud service provider may provide 10 to 11, 1 slot, 1 hour, 1 to 2 p.m. another slot, 4 p.m. to 5 p.m. another slot. Or if the resource is available, it can give 10 a.m. to 1 p.m. directly. So it is giving more flexibility to the cloud service provider in order to provide the resources. So it is taking both things. One is AR mode as well as the non-primitive based performance. Okay. For example, it will say that within this 1 hour you cannot print it. But once our 1 hour is there, then you can print it. That is called your AR nature. If 30-minute slot is provided, then it will say that within 30 minutes you cannot print it. But after 30 minutes you can print it. And non-primitive based effort means once you are assigning, you have to complete the duration. 30 minutes or 1 hour duration, whatever you committed, you have to do it. But once it is over, then you can pass on the things with two other cloud service providers. That's why I've given the things as reserved slot. These slots are reserved for some other leases. Next is called your token reservation. So early days, what happened? Whenever you are going for a banking system, so once you are going to the banking system, they will provide you the form. Let's say withdraw form or deposit form. You have to fill up this form, and you have to again submit this form to a particular cashier. The cashier is going to provide you a token. Okay. Then there is a display machine. When your token number will be displayed, you have to go to the counter for deposit operation, or you can say withdraw operation. Right? So token reservation lease is a kind of lease that alert the lease manager when the token is about to expire. For example, there is a long queue, so you got a token, but your number is very far away, whatever displayed in the. So you can go outside, you can do your work, and after some time you can come and receive your deposit your things, or you can withdraw your things. Okay. So in order to compare, in order to make this logic in the cloud service, in the cloud context, what happened? Token reservation is proposed. Token reservation maintains 3 parameters. One is your token issue time. At what time the token is issued to you. Token expire time. Obviously, the token expire time is nothing but the closing time of the bank. Another is called token alert time. Token alert time means suppose performing a particular operation required 10 minutes. So closing time minus 10 is called your token alert time. So these 3 things you have to specify in order to submit your release in the token reservation mode. Just see one example. So there are 3 cases in this case, right? Token issue time is nothing but arrival time, as I mentioned here. Arrival time, so it is a very simple one. We do not require that, but we have to deal with time and alert time because you have to do that operation in that particular day only. Other days it is not allowed. First case is the token reservation lease has completed before the token alert time. The token reservation lease is completed before the token alert time. For example, you need a particular operation, and that operation required 10 minutes. and bank is closing at 5 p.m. So 4:50 is the last deadline. If 4:50 will not start the work, 5 o'clock the bank is going to close. But what happened? Your alert time is what? 4:50. If 5 is the closing time, your duration you have specified 10 minutes. 10 minutes is the operation. So before 4:50, let's say the lease is completed. What you will do? In this case, your job is done. So lease manager does not have any rule. There is no rule because before your alert time, the things is completed. But the second thing is that the lease has not started up to the token alert time. Means up to 4:50, it has not started. What happened? The manager has two choices. One is first choice is it will convert the token lease into immediate lease. Immediate lease means arrival time is same as your start time. So immediately need to start the work. Otherwise, it will be not complete before the closing time. Next one is if the resources is not sufficient, if all the cashiers are busy, then what it will do? Some new cashier will come or some other person who are there busy in other work, right? They have to come as a cashier and do the operation in order to complete before the closing time. So you can see in the first case, okay, there is a token reservation, but in this case, what happened in the first case? It will be converting the lease into a immediate lease and doing the work. For example, I require 2 hours. So 1 hour is given here. My deadline is at 5 p.m. So another 1 hour you have to specify give in this slot 4 p.m. to 5 p.m. If I require 2 hour slot. On the other hand, if all the resources are occupied up to 3 p.m. because I require 2 node slot, right? So up to 3 p.m. that is my token alert time. The resource is not provided to me. So what you have to do? You have to start another resource in order to accommodate the token reservation. So in the first case, the lease is partially completed. That's why you are updating the token arrival time, token alert time, because token arrival time is at 3 p.m. But once you are giving 1 hour slot, it is updated to 4 p.m. Right? And if it is not updated, you are bound to start at 3 p.m. Otherwise, the lease will not be completed. Right? For that, you may need to convert the token lease into the immediate lease, or you need to start new resources in order to fulfill the work of the user. In order to fulfill the requirement of the user, you have to do it. The next important lease and perhaps the last lease is called as your advertisement lease. Advertisement lease, what happened? All the resources of the cloud service provider is not occupied. Okay, all the resource slots are not fully occupied. So what happened? The vacant slots may be advertised. Cloud service provider will advertise the vacant lease just like an advertisement. And if anybody is interested, so they may claim. So if a particular slot is claimed by multiple people, then we will see in which case we will get more revenue. The case where we are getting more revenue, we are going for it. Okay, that's why it says an advertisement lease announces the free periods that are associated with the resources. The customer may choose an advertisement period or lease which is closely matched to the demand. For example, one advertisement is 5 nodes are available. Another advertisement is 3 nodes is available. Another advertisement is 1 node is available. Your requirement is 1 node, then you will go for 1 node. You will not go for 3 node and 5 node. Because in the 3 node and 5 node case, you have to pay more. Right? For example, let us take an example to understand this thing. Lease manager announces 3 advertisement periods. For example, it is saying 2 node 2 hour period is available here. 2 node 2 hour period. So it is 11 a.m. to 1 p.m. 2 hour to 2 node, that is node 4, node 5, and 2 hour duration means 11 a.m. to 1 p.m. is available. Another one, it is saying 3 node 2 hour period is available in between 1 p.m. to 3 p.m. Next is a 1 node 2-hour period is available in between 4 p.m. to 6 p.m. Let's say three things are advertised by a lease manager or by a cloud service provider. Let us see what will happen. A customer require 1 node 1 hour 30 minutes. Here 1 hour 1 node 1 hour 30 minutes is required. So there is three things advertised. One is 2 node, another is 3 node, another is 1 node. But what is our requirement? Our requirement is 1 node for 1 hour 30 minutes. So in what way you are going to assign? What way you are going to assign? You can apply the first fit approach or best fit approach or roast fit approach. In the first fit approach, you can see the first one you are going to assign. Even if it is advertising for 2 node 2 hour, you are asking only 1 node for 1 hour 30 minutes. It will be provided in this way, in the first fit manner. Okay, that's what it's saying. It selects the first advertisement needs period for the customer requirement 1 node 1 hour 30 minutes. You may go for the best fit approach. Best fit approach is which one? The last one. It is 1 hour to 1 hour to 1 node 2 hour. You require 1 node 1 hour 30 minutes. So this is the closest fit. You are going to only left with 30 minutes slot. So if you are following the best fit approach, you will fit the customer requirement in this case, right? But if you go for the roast fit, what you are going to do here? In roast fit case, you have to find the maximum available resources. That is nothing but the 3 node 2 hour period. In that you are going to assign 1 node 1 hour period, 1 hour 30 minute period. So in this way, you can assign the list. This is the best fit pattern. Similarly, you can go for the roast fit approach representation, or you can go for the first fit approach representation. Right? Now, which one is okay? The last, okay, I think this is the last. Okay, another list is there. That is called as your soft and hard deadline list. Soft deadline means you can violate that deadline with some penalty, but hard deadline you cannot violate it. For example, in this list I have specified I require 2 hour slot. I need 5 resources. Okay, and my soft deadline is 3 p.m. and my hard deadline is 5 p.m. And if you are violating the deadline, soft deadline, you will be charged a penalty of 50%. So let us see an example. So my deadline is 3 p.m. That is my soft deadline. 5 p.m. is my hard deadline. So what happened here? Cloud service provider, I requested 2 hour slot as a customer. Cloud service provider may provide one lease at 10 a.m. to 11 a.m. Another may be 2 p.m. to 3 p.m. in order to meet the soft deadline, in which if you are meeting the soft deadline, you are not going to pay the penalty. But what happened in the second scenario? The soft deadline is violated. The soft deadline is violated, means up to 3 p.m. cloud service provider has not provided you the resources. So it is bound to provide the resources at 3 p.m. in order to complete the task at 5 p.m. Okay, that is your hard deadline. And 50% penalty means if you have committed for $1,000, then you are going to pay for only $500. Okay, this is called as your soft or hard deadline list. So this is the cost model. I am not going through this cost model because it is a little bit complex one. But which lease is more costly? If you compare advanced reservation with best effort, obviously advanced reservation is more costly. Advanced reservation is more costly because it is specific time. If you are asking the resource for a specific time, obviously the cost is more rather than because there is no flexibility. But best effort, there is a lot of flexibility. But if you compare immediate with advanced reservation, immediate says that right now I require the request. I require the resources for my request. So what will happen? You are going to provide it, otherwise there is a violation. Or you can say no, the resource is not available. So obviously, if you compare these three, you can see immediate has more thing, then immediate is more costly than the advanced reservation. Advanced reservation is more costly than your best effort. And if you see the probable, which lease will be accepted more? Obviously, best effort lease will be accepted more. Advanced reservation is second. Immediate is third. Because if you put so much deadline, there is a chance that your lease may not be fulfilled by your cloud service provider. Right? Similarly, non-primitive best effort is more costly than the best effort. With primitive best effort, right? Similarly, if you compare with the probable one, which one will be accepted first? So if there is a primitive version of the best effort, which we call as deadline sensitive lease, is more probable to accept in comparison to the non-primitive best effort, in comparison to your advanced reservation, in comparison to limited. Like that, if you compare all these, finally you are going to get this sequence. Right? So you may explore this thing by applying your own logic, because I told you the theory. You find which lease is more costly. Okay? If you are going this, finally you are going to get the final sequence is this one. Right? Is which cloud service provider is using which type of lease. Right? Whenever you go for AWS, AWS is providing you EC2, Elastic Compute Cloud. So they are treating each and every customer request as in the best effort mode. And if you go for Nimbus, Nimbus is using the immediate mode. Eucalyptus is using also in the immediate mode. Open Nebula is providing you the best effort mode. But whenever you go for Hygia Open Resource Manager, it is providing the leases in three different modes. One is immediate, best effort, and advanced. If you are representing three different modes, then you have a lot of challenges. That's why in the research, people specifically use this idea of a resource manager. Okay, so these are the various cloud toolkits, and they are